So solar radiation, remember solar radiation is greatest near the equator and it decreases towards the pole. I hope remember in the very first class I took it's because of the angle of insolation. It's because of the angle of insolation with respect to the latitude, because of the curvature of our earth. The different latitude used to receive different angle of insolation at different point of time. The very first class I told you. So the solar radiation is greatest at the equator because at a given point of time there will be a maximum insolation. The maximum angle of insolation will be there on equator, sometimes 90, sometimes 66 and half. And on the polar parts, I hope remember 6-month day, 6-month night. That means what? The sun is not present. If sun is not present, that means there is not that much heating which is actually taking place on equator. So solar radiation, I mean this heating, you can say heating of our earth's surface or the solar radiation depends on what? Depends on the angle of incidence, duration of daylight, transparency of atmosphere, and yes, the earth's distance from sun. I hope you remember with respect to the aphelion and perihelion. We learned about these things in the very first class. Okay, so it's because of the solar radiation our earth's surface used to form. Now let's see that what are the ways, or let's say what processes are there through which the earth's surface used to warm or cool. So first of all we could have a reflection. We have what? Reflection. Here this is the perfect example of reflection. When there is a bounce back of energy back into the space, back into the atmosphere because of the surface or because of the any shiny object on the surface or in the atmosphere. They will be what? They will be a reflectivity. You will see that the clouds, snow and ice, which is so they will show a high reflectivity. Okay, because there are crystals in ice, there are crystals in clouds to some extent, and yes, in the ice we have a crystal. So crystals have a property to reflect the sunlight. And yes, polar region have what? High reflectivity. Here you can assume that on the polar parts we have what? Frozen state, we have ice, we have what? Some sort of snow. As a result of that, there will be a reflection. Then we could have a scattering. So when we have a deflection of solar rays because of the gases and dust particles, in atmosphere I told you atmosphere is comprised of solid, liquid and gaseous components. So when we have those solid components, solid particles, specifically dust particles and some gases if they are present in the atmosphere, and when the sunlight is interacting with them, as a result of that what will happen? There will be a scattering. What? Scattering of light. And yes, because of the scattering, I hope remember I also told you that because of the scattering we have what? Blue and this orange color in our sky, especially during the sunset and during sunset. We used to term it as a Rayleigh scattering. Then we could have an absorption, that certain gases like ozone, CO2, water vapor, they used to absorb the radiation. They used to absorb the radiation. I told you ozone absorb what? Ultraviolet radiation. Ultraviolet rays is being absorbed by ozone. Then we could have a transmission. So when the energy passes through atmosphere, reach the earth's surface, this is what the simple transmission. Okay, when it is passing through the atmosphere, we have a clear sky condition. When we have a clear sky condition, there is a direct transmission of insolation from the top of our atmosphere towards the earth's surface. So this is what the transmission. I hope there is a very basic, these are very basic things. Hope you have a clarity with respect to this. So when we have a top of atmosphere, or let's say the earth's surface, when we have a propagation of these waves, transmission, then they used to reflect because of the shiny objects, reflection will be there. We could have a refraction when there are water bodies. Water bodies, if you see from sky, sometimes they are also shiny. So yes, water bodies are also reflecting some part of sunlight, some part of sunlight. Okay. Then we could have absorption by the surface, and yes, we could have a certain gases in atmosphere which used to absorb this set of incoming solar radiation, and yes, we could scattering because of the solid particles present in atmosphere. So it's because of these processes. We have a heating, specifically heating at the earth's surface, and so many phenomena in our atmosphere which we use to. Moving ahead, cooling. So when there is a terrestrial radiation, now what is a terrestrial radiation? Terrestrial radiation is that radiation, long wave radiation. This terrestrial radiation or long wave radiation is actually being released by the earth's surface. Why earth used to release it? In order to maintain thermal equilibrium, in order to maintain or in order to release that excess temperature which has been absorbed because of the insolation. As per the law of thermodynamics, in order to attain the thermal equilibrium state, earth used to release back that excess heat in terms of long wave radiation or terrestrial radiation or infrared radiation. So earth absorbs short wave solar radiation and re-emit energy as long wave radiation. Here you can see we have what incoming insolation, and this excess insolation which is there. So this excess insolation will be what? Radiated off by Earth's surface. In atmosphere we have a certain gases, and these gases will going to trap that radiation. In atmosphere, for example, we have what? CO2. So this CO2 will going to trap this long wave radiation, and when this CO2 will going to trap this long wave radiation, it's because of the low energy. Because of the low energy, the CO2 will going to absorb that long wave energy, and when the CO2 will going to absorb this long wave energy, it will going to re-radiate that heat in atmosphere. So here in atmosphere we have what? This heat which has been re-radiated. What will be the result? The result will be what? The temperature of atmosphere will going to increase. The temperature of atmosphere will going to increase. It's because of CO2. Now, similar to the CO2, we have what? Water vapor. Similar to CO2, we have what? Ozone. Similar to CO2, we have what? Oxides of nitrogen, oxides of sulfur. Then we have what? We have this chlorofluorocarbon. All of these have a property of what? Warming of our atmosphere by trapping the long wave radiation releasing from our Earth's surface. Net result will be what? That the average atmospheric temperature will be increased. Now we have a natural balance, but it's because of human activities, it's because of the anthropogenic emission. We have released a lot of CO2 in atmosphere, we have released a lot of nitrous oxide, we have released a lot of we can say some sort of oxides of nitrogen and sulfur. We have released a lot of chlorofluorocarbons, and it is because of that excess amount which has been released that will going to trap the long wave radiation, and the net result is what? The average temperature of atmosphere is increasing. This we used to refer as what? Global warming. This we used to refer as what? Global warming. Okay. So this outgoing radiation heat the atmosphere from below as gases like CO2, H2O means water vapor, and yes, methane, if it is that. Methane is also greenhouse gas. This impact is known as what? Greenhouse effect. What happened in greenhouse? See, this is the Earth's surface, and we have a long wave radiation. As there is a long wave radiation, there will be a releasing of what? Sorry, as there is a short wave radiation, there will be releasing of what? Long wave radiation. Because of the long wave radiation, Earth used to get what? Cool, and because of this red short wave radiation, Earth used. This is the natural, okay? This is the natural way in which heating and cooling of Earth used to take place. Now, naturally, the thing here is, in order to make atmosphere habitable, in order to make living condition, in order to make our Earth habitable, there are certain gases like CO2, like methane, for example, like water vapor. They are there in our atmosphere and they are being released. CO2, I hope you remember in volcanic eruption we learned that because of the volcanic eruption we could have a CO2, we could have a methane, we could have water vapor in our atmosphere. And it is because of that volcanic eruption, suppose there are naturally greenhouse gases, in order to make our atmosphere warm to some extent so that the habitable condition could be developed on our earth's surface. They are natural as of now. Now what will be the repercussions of this? That when we have a long wave radiation, so this methane will going to trap, this CO2 will going to trap, and this water vapor is going to trap, and that's how there will be a some sort of what increased temperature on our earth's surface, or let's say in atmosphere, because of which the living conditions are existing, the temperature is there.